What if I told you that one of chemistry's coolest tricks can turn a liquid into dazzling solid crystals, just like magic? This video covers that, a separation technique known as crystallization. Crystallization is used to separate soluble solids from a liquid mixture. The technique consists of an evaporation dish, the solution to be separated, the tripod stand, and a heater like the Bunsen burner. To initiate crystallization, the solution is gently heated until it reaches a state of saturation. This means that the solution holds as much solute as it can at that specific temperature. Then, the saturated solution is allowed to cool down. This causes the formation of crystals. The crystal formation during cooling is linked to the solubility of the solution. As the temperature decreases, the solubility of the solution diminishes, causing the dissolved solutes to change into solid crystal structures. This relationship between temperature and solubility is the key to the success of the crystallization process. Once the crystals have formed, they can be separated from the solution. Did you know that some of the world's most expensive crystals, like quartz and sapphire, can be artificially grown using controlled crystallization techniques? That's right, high-tech labs can mimic nature's process to create perfect, flawless gems. To recap, crystallization is a separation technique used to extract crystals from a solvent. It separates solute solids from a liquid mixture. The solution is heated to saturation and then allowing it to cool. This method exploits the temperature-dependent solubility of the solution to produce distinct and pure crystals. And that's the sparkling truth about crystallization, a technique that turns chemistry into art. Now that you're crystal clear on this separation technique, in the next video, we'll explore fractional distillation, science's way of separating liquids.